Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So we meet again today in our class. So this week we will start with a new chapter, Shear Strength of Soils. So actually this chapter will be taught by Mr. Muhammad Azril Hazmi, but I just want to give you a quick glance through of what you will learn with him. Okay. I already upload the shear strength notes. We will use almost similar slides. I just put in the e-learning some review as a kickstart of this chapter. I hope you will understand at the end of the first part of Mr. Azril video that you will learn on shear strength. Shear strength is a resistance of soil itself to sustain the force applied via the shearing stress, because usually we only learn about normal stress, the straight applied stress. If I could share with you the difference. Okay, this one. So this is, do we have the, okay, okay, so this is how normal stress usually looks like. But in shearing, so we can have two different arrow in different directions, but applying at a similar surface. So that's what the soils usually do. So the resistance between the soil grains from each other, from the soil particles to another soil particle, will grip. If it is a strong grip, so the soil will become strong. It will not fail. But if the shear strength is very weak, they doesn't have any grip between one direction to another direction, means the upper layer of the soil, if you imagine this is upper layer of the soil, and the below layer of the soil, different soil particles doesn't have a good grip between them. They hold on to each other, so they might failure much more easily. So this is normal stress and this is shear stress, similar to shear strength and normal strength. Okay, so that's the definition of the strength of the shear. If I open again there. Okay, and then number 2, okay, shear, the soil derives its shearing strength from the resistance of the interlocking between the particles. So if you have two particles, so it is interlocked between each other, and also the frictional resistance between the individual soil grain. So later on, if you can see later in the slides, and also Mr. Azril will mention about angle of friction, and also the cohesion, which is actually mentioning about the resistance, frictional resistance, and also cohesion is actually the adhesion between the soil particles. So the soil stick to each other, sticky. If you can still remember the clay and silt, a very fine soil can have a cohesion. So those is the parameters, or the how the soil derive its shear strength. So the soil itself have their own shear strength, and different type of soil have a different types of strength. Okay. And I would like to mention also as the soil is a particulate materials, a grain soil, so the shear failure of the soil is slippage of particles due to the shear stress. So according to the Moore, it's a name of people. Okay, Moore later on introduced a Moore Coulomb. So later on in the video of Mr. Azrael, you will see he will mention about Moore Coulomb a lot of time. So this is the principle of the shear strength that we will learn in our class. If you go to further class of master and PhD level, we actually have a lot of theory, but for the undergraduate class, we limited to the Moore Coulomb only. Okay, this Moore's a researcher, he said that the failure of the soil usually caused by a critical combination of the normal and shear stress. So you still remember normal, how's the normal and how the shear stress. So combination of these two magnitude will lead to the failure of the soil. And at the failure, soil have a failure plane. Later on when you go to video Mr. Azrael, please catch up the terms that he used. A failure plane is a straight line if in two-dimensional, but actually in real situation, it is like a slippage. I forgot what the terms, but it is actually a 3D failure plane. It's not 2D. And then, okay, why we want to learn about shear strength? So it is important to learn because we want to estimate the capacity of the soil, the bearing capacity that the soil can take up by its foundation. And in this foundation is things that we put before we build any building. We have a shallow foundation and we have a deep foundation. Okay, and besides about foundation, we want to assess the stability of the retaining walls, slopes, embankments, and so on. Okay, I would like to share with you a video. Okay, how much time that we have? Okay, wait. Alright, still have time. Okay, so let's see, this is a landslide, a catastrophic event due to the very low shear strength of a soil. So, okay, initially we see the cars, but we don't see anymore. So we can see, okay, this is a failure plane. Failure plane, if I can take my arrow here. So, okay, and next we can see, okay, this is straight or almost in the V shape of failure plane. The failure plane not necessarily be in a circular manner. It could be a line or be a combination of 2 to 3 planar lines. Okay, this is also a straight planar lines. So it means that the shear strength of the rocks and the shear strength of the existing rock inside is doesn't grip to each other. Another failure you can see. Okay, cannot see the failure lines here, but we can see there's a lot of debris flow due to the weak plane. And another failure. Okay, I think this one is interesting. Initially, we only have a small slope failure. You can see that the V shape become a much more bigger and bigger. and become a circular failure lines. So just want to wrap up. So that's why it is important to study the shear strength. So I hope I hope you try to understand as much as you could when you follow the class conducted by Mr. Azril later on. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.